Welcome to the first chapter of SQL Fundamentals 1 course presented by Sahai Education. This is Deepak Pal Singh, and in this chapter we will discuss the most commonly used statement in SQL, the select statement. The select statement is used to retrieve data from the tables. Since select is the only SQL command that can be used to query data from the database, it is also known as a query. The select statement is capable of performing 3 of the 9 relational operations that we discussed in the introduction chapter. These 3 operations, also known as the select statement capabilities, are projection, selection, and joining. Let's review these capabilities once again. Projection allows you to pick a subset of the columns in a table. It enables you to retrieve only the required columns from the table, discarding the rest. For example, you can use the select statement to pick just the name and salary columns from the employee table, discarding the employee ID column. Selection allows you to pick a subset of the rows in a table. It enables retrieval of just the required rows, discarding the rest. For example, you can use the select statement to retrieve the rows for just department number 10, discarding those for department number 20. The final capability, joining, allows you to combine data from multiple tables using a single select statement. It is used where the query cannot be satisfied from data in a single table. The tables are joined based on the relationship between certain common columns in the tables. For example, to retrieve the department name for employees, we need to join the employee and the department tables. The relationship between these tables is defined by the common column department number. To summarize, the select statement is used to retrieve data from the tables and is also known as a query. It has 3 main capabilities. Projection allows you to retrieve a subset of the columns in a table. Selection allows you to retrieve a subset of the rows. And joining allows you to combine data from multiple tables. Let's see how to write a simple select statement next. Like English sentences, SQL statements are divided into clauses. Each clause performs a specific function in the SQL statement and consists of an operator and the relevant input values. The select statement in its simplest form is a combination of 2 clauses, the select clause and the from clause. The select clause specifies the columns to be retrieved and the from clause specifies the table containing those columns. All SQL statements must terminate with a semicolon to signal the end of the statement and submit it for execution to the database engine. For example, to retrieve the name and salary columns from the employee table, we would write select name, salary from employee. Here, name and salary are the columns to be retrieved, and employee is the table containing these columns. To retrieve all columns from the employee table, we could either list them all one by one, for example, select ID, name, salary from employee, or use the special character asterisk, which Oracle expands to all the available columns in a table. Let's practice these statements on a real database. On the course homepage, you'll find a link to download the practice virtual machine that is supplied with this course. The VM contains a sample database to try the examples included with this course. Once the download has finished, unzip the downloaded file to extract the relevant directory and file structures. To start using the VM, you need to download and install the VMware Player, which is available free of charge on the VMware website. Once installed, launch the VMware player from the Start menu. Click on Open a virtual machine. Navigate to the extracted VM directory and select the shown VM image. This will add the VM into the VMware Player library. To boot the VM, right-click on it and select Play Virtual Machine. On the login screen, type Oracle as the username and Oracle as the password. As discussed in the introduction chapter, a SQL development environment such as SQL Star Plus is required to connect to the database and execute SQL commands. To launch SQL Star Plus, right-click on the desktop and open a terminal session. Type SQL Plus in the command window and hit enter. As shown, you will be prompted for the database login credentials next that are set up by the database administrator on your behalf. To connect to the sample database, type Scott as the username and Tiger as its password. Once the database connection has been established, you can start entering the SQL commands. Let's retrieve the available columns in the EMP table included with the sample database. On the SQL prompt, type select star from EMP. Finish the statement with a semicolon and hit enter. As seen, the default display in SQL Star Plus is not very user-friendly. This is because SQL Star Plus formats the display of select statements according to a predefined page size. The concept of page size is very similar to the page setup in Microsoft Word. In SQL Star Plus, the default page allows 80 characters per line and 14 lines per page. Looking at the output on the screen, rows exceeding 80 characters per line are shown wrapped on to the next line. Similarly, where the output exceeds 14 lines, a new page is started and the column headings are displayed again at the top of the new page. To improve readability, we need to take two steps. The first step is to increase the number of characters allowed on a single line such that each row is able to fit on the same line and is not wrapped on to the next. For example, to increase the number of characters per line from the default to 200, type set line size 200. The set command is a SQL Star Plus command and is used to alter the environment for the current SQL Star Plus session. Being a SQL Star Plus command, it is executed locally by the SQL Star Plus environment and is not forwarded to the database engine for processing. Also note that unlike the SQL commands, SQL Star Plus commands do not need to be terminated with a semicolon. Let's re-execute the above select command and see how the output differs with the modified setting. As seen, the display is much better now. However, we can still improve by eliminating the repeat column headings. This can be achieved by fitting all the rows on a single page of display. Without a new page, column headings will not get displayed again. The following command increases the number of lines that can fit on a page to 200. To verify the impact of the new setting, re-execute the above select statement. As seen, the output is much more user-friendly now as compared to the default display. Let's analyze the command output next. The employee table contains a total of 8 columns. From left we have the employee ID, employee name, job title, manager ID, hire date, salary, commission, and department ID columns. Numeric columns are displayed right-aligned, while date and character columns are displayed left-aligned. Column headings are always displayed in uppercase. There are 14 rows in the EMP table, one for each of the 14 employees working in the organization. For each employee, the row stores 8 different units of data corresponding to the 8 columns in the table. For example, in the first row storing information about Smith, we have his employee ID as 7369. Smith is working as a clerk, reports to an employee with ID 7902. He was hired on 17th December 1980, receives a salary of 800, doesn't receive a commission because clerks are not entitled to one, and he works in department number 20. One interesting thing to note about Smith is that he does not receive any commission. Notice how that is indicated by a null value in the commission column. Any value that is unavailable, unassigned, unknown, or inapplicable in Oracle is represented by a null. The null is not the same as a zero, and it is not the same as a blank space. 0 is a number and blank space is a character. Null signifies the total absence of any value. The last line of the output is called the feedback and is only displayed when the output contains more than 5 rows. SQL commands are not case sensitive. You can enter the above command in lowercase, uppercase, or even mixed case without any change in the result. For example, that said, it is customary to type keywords in the uppercase and arguments in the lowercase. For example, until now, we have illustrated the use of asterisks to fetch all the columns from a table. To retrieve a subset of the columns, we need to list the column names explicitly in the select clause. For example, to retrieve the name and salary columns from the EMP table, type select ename salary from the employee table. Now, before we move on to the next topic, let's see what happens if a SQL statement is not terminated with a semicolon. As shown, SQL Plus opens a new line assuming you have not finished typing the command yet. To signal the end of the statement and submit it for execution, put a semicolon and hit enter. Let's learn a few tricks about SQL Plus before proceeding further, since we'll be using them throughout this course. To re-execute the last command, type a / and hit enter. As shown, it retrieved the ename and salary columns again without you having to retype the previous command. SQL Plus makes this possible by storing the last executed command in an internal buffer. To view the contents of the buffer, type L. To display the buffer contents and execute them in one go, type R. To edit the buffer before re-executing the command, use the ed command. The ed command opens the buffer using the default operating system editor to allow you to modify the contents. For example, add another column to the select list, save the buffer, and exit. As seen, the modified command will be displayed on the screen. To execute the command, use the / or the R command. Let's now continue with our discussion of the select statement. Oracle allows you to specify the values directly in the select clause instead of retrieving them from the columns. For example, values specified directly are called literals or constants because their value remains constant for all the rows in the table. In comparison, the values in a column can vary across the rows. Notice that the column heading for a literal is derived from the literal itself. Literals of the character or date data types must be enclosed within single quotes. For example, if they are not, Oracle interprets them as column names. For example, since the working column does not exist in the EMP table, an error is returned. To summarize, in its simplest form, the select statement consists of two clauses. The select clause specifies the columns to be retrieved, and the from clause specifies the table containing those columns. You can control how SQL Plus formats the select display by altering the line size and page size environment settings. SQL Plus stores the last executed command in an internal buffer, the contents of which can be viewed and modified before re-executing. Values specified directly in the select clause are called literals. The value of a literal remains constant across all the rows in the table. The next section discusses how to perform calculations with the select statement. Oracle provides you the ability to perform calculations with the retrieved data as part of the select statement. Since select is a read-only operation, the calculation modifies the data for display purposes only. Actual data in the table is not affected. For numeric calculations, 4 operators are provided: add, subtract, multiply, and divide. Let's see an example. To calculate the twice of employee salary, we would type select the employee name, the original value in the salary column, and salary multiplied by 2 from the EMP table. Recall from the previous section that a literal value remains constant for every row in the table. Therefore, in this query, the value of salary column in each row is multiplied with the literal 2. The following query increments the commission for each employee by 500. Notice that for rows containing null values, Oracle evaluates the calculation to a null. This is because expression containing an unknown value cannot yield a known result. By design, they must evaluate to another unknown value or null. Oracle evaluates the expressions containing multiple operators according to the rules of precedence. In the case of numeric expressions, multiply and divide operators have higher precedence and thus are evaluated before the add and subtract operators. For example, in the following query, $200 multiplied by 3 is evaluated first and the result is then subtracted from the salary column. Operators with the same precedence are evaluated in the order that they appear in the expression. For example, Since multiply and divide operators have the same precedence, the salary column is multiplied with 3 first, and then the result is divided by 2. It is possible to override the default order of operator precedence by using parentheses. Here, since salary minus 200 is enclosed within parentheses, it is evaluated before the multiply operator. Sometimes, especially in the case of expressions, the default column headings may not be appropriate or up to your liking. Oracle allows you to rename a column heading by using column alias. An alias is the new name for a column and is specified immediately following the column name in the select clause. For example, the following query increments the salary column by 200 and then renames the column heading to new salary. New salary is the column alias here and immediately follows the column to be renamed. An optional as keyword may also be specified between the column name and the alias for clarity and understanding. For example, the above command may be rewritten as if the alias contains spaces or special characters, it must be enclosed within double quotes as shown. Besides numeric operators, Oracle provides operators for use with the character values. The two available character operators are the concatenation operator and the quote operator. The concatenation operator is used to combine character strings and is represented by two vertical bars. Let's see an example. In this query, values in the ename column are concatenated or joined with the specified literal string, and the resulting column is then renamed using an alias. It is also possible to combine more than two strings by linking them with multiple concatenation operators. For example, since two concatenation operators would have the same precedence, the operators in this query are evaluated in the order that they appear. So, the ename column is first concatenated to the literal string and then the result is joined with the job column. As we know, all character and date literals must be enclosed within single quotes to differentiate them from the column names. This can create a problem where the string itself contains a single quote. For example, the following statement uses an apostrophe s within the literal. The statement terminates with an error because Oracle interprets the second single quote as the string terminator instead of the final one. To get around it, escape the second quote with another single quote. For example, here, the second single quote escapes the third quote to make it a part of the literal string. Using a quote to escape another can quickly get confusing where a string contains multiple quotation marks. For such cases, Oracle provides a better alternative in the form of the quote operator. The quote operator uses a delimiter character on either end of the string to escape all the single quotes enclosed within. You can choose any character of your choice as the delimiter or one of the following character pairs. Let's rewrite the previous query using the quote operator and the square brackets as the delimiter pair. As shown, the query is easier to read and understand with the quote operator. To summarize, Oracle provides numeric and character operators for performing calculations as part of the select statement. 4 numeric operators are provided: add, subtract, multiply, and divide. Character operators include the concatenation operator to combine strings and the quote operator to escape single quotation marks within a character string. And finally, you can use column aliases to rename a column heading to a more descriptive name. In the next section, we take a look at eliminating duplicate rows in the select statement. Sometimes you may want to see the result of a select statement after eliminating all the duplicate rows. For example, in the following query, we attempt to find the existing job categories in the company. As expected, Oracle displays the value of job column for every row in the EMP table, thus repeating the job categories many times over. By eliminating the repetitions, we can make the output much more easier to understand. To do so, use the distinct operator immediately following the select keyword as shown. As seen, only the distinct job categories are displayed now. The distinct operator affects the entire row and not just the column immediately following the keyword in the select clause. So, if multiple columns are selected, the result is every unique combination of the columns. For example, the following query finds every distinct combination of the department number and the job columns. Oracle provides a way to find information about the columns contained in a table without displaying the data. This is done using the describe command. To display the structure of the EMP table, type as seen. The describe command tells you the names of the columns that exist in the EMP table, the type of data that can be stored in those columns, and whether the columns can contain null values. The following data types are available in Oracle for storing data: number to store numeric data, char and varchar2 to store character data, and date to store the date values. Although it is possible to store number and date values as character strings, Oracle provides special data types optimized for the purpose. This brings us to the end of this chapter. As part of the first chapter, we have learned about the select statement, which is used to retrieve data from the tables in a database. Out of the 3 capabilities of the select statement, this chapter only covered the projection capability, that is, retrieving a subset of the columns from a table. In the next chapter, we will discuss the selection capability to retrieve only the required rows from the table.